Welcome, ladies and gentlemen, to Chapter 12. The topic of Chapter 12 is radicals. We will be simplifying radicals, adding, subtracting, multiplying, and dividing radicals. We will be taking square roots, cubed roots, fourth roots of different expressions. Let's start with a little bit of review from Chapter 1. Real numbers. The real number line can be broken up into two parts. The rational numbers, which include the counting numbers, numbers you can count on your fingers and toes, also known as the natural numbers. Add 0 to that, you get the whole numbers. Take numbers and their opposites, and you get the integers. All right. Rational numbers would also include the fractions. We can include fractions in that list. Irrational numbers are your non-repeating, non-terminating decimals. Non-repeating, non-terminating decimals. And it includes things like pi, for example. All right. Well, if we're doing radicals, then why on earth would we be talking about irrational numbers? Well, radical 3 is an irrational number as well. If I take the square root of 3 on the calculator, it is not going to terminate. It is not going to repeat. So radicals, some of them are rational, some of them are irrational. Rational numbers value can be expressed as a fraction. For example, 1/3 is 0.3 repeating. It's a repeating decimal. I can write it as a fraction. Irrational numbers cannot be expressed as a fraction. If they don't repeat or terminate, there is no calculation that can be done to convert that into a fraction. All right, rational versus irrational numbers. Before we get into that, let's talk about the parts of a radical. You'll notice that the radical sign there, that is called a radical. You've heard me use that word a bunch of times already. Okay. The number 4 is called the index, and 81 is called the radicand. You will hear me use these words when helping you with your homework problems tomorrow in class. Index, radical, radicand. We are trying to take the fourth root of 81 here, so we have to do a little bit of brainstorming. If you think about it, 3 times 3 times 3 times 3 is 81. This would mean that the fourth root of 81 is equal to 3. And for the most part, we're going to use technology, i.e. your calculator, to do that. But that is kind of the logic behind how you would take the fourth root of 81. Perfect squares are rational. Everything else are irrational numbers. If you cannot take the square root of it, it's an irrational number. That is really important. For many of the problems that we'll be doing tonight and throughout the chapter, they're going to ask you to find the principal square root. When you take the square root of a number, because negative 5 times negative 5 is 25, just like 5 times 5 is 25, we would say, if we're being smart about it, that the square root of 25 is plus 5 or it's negative 5. However, when they ask you for the principal square root, they only want the positive one. And usually we want the positive one. But there's been many good mathematicians that have fallen down because they forget that the square root of 25 is also negative 5. All the roots. If I'm asked for all the roots, I not only want to list 4, but also negative 4. So I can use the plus minus symbol to answer example 1 here. Positive 4 is the square root of 16, but negative 4 is also the square root of 16. Rational number. Can you take the square root of 2? Can you take the square root of 8? Can you take the square root of 25? Can you take the square root of 20? Since you can take the square root of 25, it is the rational number in the list. Square root of 25 is 5. Alright, give as a rational number with the appropriate sign. Square root of 49 is 7, so the answer here would be 7, and it's positive. Now, this is negative 1 times radical 16. So when you take the square root of 16, that negative 1 is going to have to get multiplied by that answer in the end. Cubed root. Ooh, this is going to be exciting. When you want to take the cubed root, let's use our calculator to help us do this. I'm going to put in 64. I'm going to raise this to the, now I want the cubed root. Here's the trick. Put 1/3 in the parentheses. So you notice that the root is the denominator of that fraction. And this will give you the answer. So positive 4. You can also try to take roots of negative numbers on here. I'm going to put 64 in parentheses though. Make sure that the calculator isn't telling me the order of operations. I'm the boss here. I'm going to tell the calculator what to do. And the parentheses allow us to tell the calculator what to do. So this is what you would have for number 4 here. Negative 64 raised to the 1/3 power. And it is, negative 4. So you can take the square root of, or I'm sorry, the cubed root of negative numbers. You can take the cubed root of a negative. And that's an important fact. How about the cubed root, or the negative cubed root of 125? Well, just like we saw earlier, this is technically negative 1 times the cubed root of 125. So it will be negative 5. Alright, number 6. 4th root, no problem. What is our fraction going to become now? Ooh, can you figure it out before I write it up here? We're going to raise this to what power to take the 4th root? Ooh, I'm excited to see what you have to say. And it is 1/4. So you take the 4th root, 0.6. Because this terminates, 0.1296 is a, or at least the 4th root of it is a rational number. Now for number 7, we can be smart about this, stay away from the calculator. Rules of exponents say I can actually take the square root of 9 and the square root of 16 separately. So this becomes negative 1 times 3 over 4, or negative 3/4. That would be the example, or the answer to number 7. Well, let's solve each equation. X squared equals 25. The opposite of squaring a number is taking the square root. So I'll take the square root of both sides. X is equal to positive or negative 5. To solve number 9, I'm going to do the same thing I did in number 8, but I'm going to have to get that 36 to the other side. So I'll add 36 to both sides. Get y squared is equal to 36. Take the square root. Y is equal to plus or minus 6. Square root is a powerful tool to solve some of these equations. Same thing here in number 10. I'm going to add 48 to both sides. I get 3y squared is equal to 48. I'm going to take that 3y squared is equal to 48 and I'm going to divide by 3. Let's see. 3 goes into 4 one time, remainder 1. 3 goes into 18 6 times. I get y squared equals 16. Take the square root. Y is equal to plus or minus 4. If the directions don't ask for that principal square root, you're going to have to give negative 4 as an answer as well. Calculator time. Give the value rounded to 4 decimal places. Radical 3. Second, look at the x squared key here. Above it you'll see a blue radical sign. Radical 3. Okay, we're back. Square root of 3, 1.73205. That 5 is going to round that 0 up to a 1. So 1.7321. 1.7321. Okay, once again, when you take the square root, hit the second key, hit the x squared key, it'll put a radical sign in there for you. And then we want 4352. 4352. 65.96969. That 9 is going to round that 6 up to a 7. So 65.9697. I got my little dots here. I'll clean those off for you. And the last one here is radical 6.1504, rational or irrational. Well, frankly, I have no idea, but we can take the square root in the calculator and take a look. So square root of 6 point, I'll have to take a look here, 1504. 1504 is 2.48, and that terminates. Because it terminates, it is a rational number. Terminating decimals are rational numbers. Okay, moving on here. Find the principal square root. That means the positive root only, so you don't have to worry about plus minus. The square root of 49 is 7. The square root of x squared is x. That's it. That's all you have to do. The square root of 4 is 2. The square root of 9 is 3. The square root of a squared is a. And remember, we take the square root of b to the fourth by dividing the exponent by 2. Done. For the next problem here, the square root of 16 is 4. M to the sixth, to take the square root of that, we divide 6 by 2. Done. 0.0081, remember when you take the square root, the number of decimal places gets cut in half. So my 4 decimal places is going to become 2 decimal places. Y to the 8th will become y to the 4th. And our last problem here, square root of 64 is 8. Square root of y to the 4th is y squared. So you'll notice we did a lot of this in the last chapter. So that last section we went through very quickly. I look forward to seeing you tomorrow. Please bring your textbook to class, and have a good evening.